Okay, so this is part 2 of angles formed by chords, secants, and tangents. In part 1, we learned a little bit about a secant, and then we talked about how we find angles when two lines intersect inside a circle, on the circle, or outside of the circle. And if they intersect inside the circle, then to find the angle, you add the intersecting arcs together and cut it in half. If it's on the circle, you just find the intercepting arc or intercepted arc and you cut it in half. If they intersect outside of the circle, then there's a couple different scenarios, but essentially you find the angle by subtracting the big arc and the small arc and then cut it in half. Okay, so now let's take a look at a couple of problems where we have to use a little bit of algebra along with the learnings from last time. Okay, so in this first problem, it says solve for x. I notice first I want to identify where does it intersect, and you'll notice right here this intersecting point is outside of the circle. So I should be thinking to myself, okay, I gotta take the big arc and the small arc and I need to subtract them. So here, this is my big arc. Here's my small arc. And I need to subtract them. So first thing I would have to say is, all right, well, I need to figure out what is this arc right here. Okay, well, I could say 74 plus 86. That's 160. So if I go 360 minus 160, that means I got 200. So this is 200 degrees. Okay, now I can say, all right, well, I know the angle. In this case, the angle is 4x plus 13. That is equal to 1/2 times the big minus small. Okay. Well, that's 114. And half of that is going to give me 57. Okay, so subtract 13. So if I divide by 4, I'm going to run out of room there. So if I divide by 4 on both sides, I get 11. And let's see, do I have to, it says to solve for x, so that's my answer. So a little bit of work there to get there, but very doable if you just set it up and think about where that intersecting arc is, or intersecting point is. Okay. This one appears to be a little bit more direct. This point is inside the circle. So then when it's inside the circle, then you're going to take the two arcs. Let's get my highlighter out. There, that arc and this arc. We're going to add them together. And this time I know both of them. So I would say, all right, 8x plus 34 is going to be equal to 1/2. And then of 159 plus 53. Okay. That would be 212, which if I cut that in half is 106. Okay, subtract 34. $72. Divide by 8 on both sides. So I get 9. All right. Wasn't too bad. Okay. So just using what we learned last time to help us out. All right, let's try. I think I have 2 more here. Okay. This time, this picture right here says solve for x, and you'll notice it's right on the circle there. Okay. And that angle is 23 degrees. Okay, so that means that this is 46 degrees. Okay. Now, that means also this arc is going to be 360 degrees minus 46. That'll be what's left in the green highlighter. So that would be 314 degrees. Okay, so this is 314 degrees. So I could say, to solve this then, I would go 14x minus 22 equals 314. Okay, add 22 to both sides. I get 336. That would be 24. Solve for x. Okay, I don't have to plug back in. There we go. Okay, hopefully that makes sense. You saw one where it was outside, one where it was inside, and one on the circle. So you saw an example of each. Let's try one more. This one says, if the measure of arc DA is 23x minus 14. All right, I'm going to write that. So this is 23x minus 14. The measure of arc DB, okay, is 9x minus 4. Okay. And the measure of angle DCB is 5x plus 11. Find the measure of arc DA. Okay, lots going on here. But again, I want to start with, well, where do the two lines, in this case it's a tangent and a secant, where do they intersect? They intersect outside of the circle. So that means if I take, the angle should be equal to half of the big arc minus the small arc. So that's all I'm gonna write. Okay, so using that picture, let's go. I've got 5x plus 11. That angle should be equal to 1/2 of the big arc, 23x minus 14, minus small arc, hopefully I can fit it, 9x minus 4. You'll notice I put it in parentheses because we got to subtract that. Okay, so now I just need to simplify this equation that I've written, and then I can go from there. Okay, So let's do that. Okay, so I don't know, maybe it's... So some people like to think of that, right? Distributing the negative, that might make it easier for you to think about. So really this would end up like this. And then you could combine like terms. However you want to get there, this in parentheses should end up with like 23x minus 9x is 14x, and then negative 14 plus 4 is negative 10. As long as you get there with the correct signs, hopefully that makes some sense. Okay. And then you could multiply both sides by 2 again if you wanted. So if I multiply the left by 2, I'd get 10x plus 22. Multiply this side by 2, and that would cancel out the half, so I'd just be left with this. Obviously, there are other ways to do that if you wanted to distribute the half, but sometimes that gets a little messy. Okay, so now I'm going to get all my x's on one side. Oops, nope. 4x minus 10, there we go. Okay, add 10. So we have 32 equals 4x. Divide by 4, right? X is 8. Okay. Well, we got a lot there. Now we want to find the measure of, let's see, which one? Arc DA. Okay. So let's do that. It's 23x minus 14, right? 23x minus 14 is DA. So the measure, I guess, equals 23 times, we found x to be 8, okay. And then minus 14. So that would be 23 times 8 is 184, minus 14 is 170. So the measure of arc, right, this arc right here is 170 degrees. That's our answer. Okay. I hope that makes sense. Now you should be able to tackle this assignment. Good luck. Don't forget to write this in your planner. All right, see you later.